Welcome to this node breakdown for MARDINI 2024 with Grayscale Gorilla. This is day 15, and today's node is the Pyro Burst Source SOP. The Pyro Burst Source SOP is a SOP-level geometry node, so we can go ahead and drop down a Pyro Burst Source. You may not see anything in your viewport, just scrub to the first few frames, and you should have an explosion playing like this. Right, so over the course of a few frames, you have these particles exploding outwards. After a certain frame, they disappear. This is used for creating all sorts of explosions, and we can actually see the types over here if we go to the burst type. By default, it's explosion, so that's going to be either a ground or aerial explosion. We have muzzle flash, which is going to be this narrow explosion like that. We have shockwave, which is going to be this one, which spreads across the ground. And then we have blast rings. And these are going to be seen in massive explosions. So this is the type of thing that you would see in a nuclear explosion. So you would have this as a secondary element of a main explosion. I'm going to go back to the default of explosion and let's take a look at these settings. Shape offset simply acts as a seeding value. So this provides different variations of this explosion. Initial size is just the size of the explosion at its starting point. So every size after that is a multiplier of it, right? So you can see you have a small explosion, push it up to a larger one. The direction is just the direction of the explosion. Once again, we can choose any direction we'd like for that. And then we have the spread angle. So as I showed with the muzzle flash, the spread angle is going to cause a tighter cone as we reduce it. Right, so as we reduce it, we get closer to that sort of muzzle flash look. We can push it up for more of an aerial explosion, right? This is the type of thing that would occur in mid-air, not near the ground. The roundness of it defines how much variation we have in its shaping. So as we push this up, all of these kind of conform to the same shape. But as we bring this down, you end up with more variation. Over here under the trailings, you can see that as we reduce this, we end up with less of these trails. Trailing separation is just similar to your particle separation, so you can end up with a higher resolution set of particles. Trailing length is just going to be these trails behind each leading point. And then trailing thickness is just going to be how tight each one of these cones are. Under the burst animation, this is where we're going to control exactly when our explosion goes off. You can see over here that we have a start frame of 1 and a frame duration of 5. So from starting at frame 1, we will have this exist for 5 frames. We can move this up to say frame 20. And if we go over there, you can see that the explosion only starts at frame 20. We can also slow down this explosion by increasing the duration, so this occurs over many more frames. Generally, you will keep your frame duration fairly low, but again, that's just going to be dependent on the project. Overall expansion over here is just how much it expands over its duration. So if we increase this, you'll see that there's no change at the start, but the actual end frame is going to be much further out. We also have directional expansion, and this is going to be in the direction that we specified over here under the burst shape. So this is going to push it in the y-axis. Down here we have directional translation, and as we push this up, you can see that the explosion moves up over time. Next, we have our burst components over here. And before I explain what the scaling over here is used for, let's first understand what these are. As you can see over here, we have 3 pyro sources. We have a density, a temperature, and a burn. These are all going to be sourced into our pyro solver, and each one is going to perform a different operation inside of that solver. These are the different fields that we need for solving. Each one of these sources are represented by a different color of particles. Density is represented by this gray or white particle. Temperature is represented by the blue particle. And then there's burn, which is represented by the yellow particles. There's also divergence, which is represented by orange, and alpha, which is represented by purple. But we're not going to be looking at those in this part. So each one of these has a value over time. We can enable a noise so that each one has a variation to it, so we don't have such a uniform density value. Additionally, we can scale all of them over duration or along the trail. So if we do along trail, you can see that the leading edges don't have much, or we can invert it so that the inside point doesn't have much, right? So this really focuses on just these leading edges. And this is just going to mean that we're sourcing in lower values at the center point and higher values towards these edge points. And I'll show you how to actually source this shortly. So lastly, we just have these output attributes over here. And this is just going to control things like our particle scale. This is going to become important when we actually rasterize these and turn them into volumes. But you can see that we have a p-scale over here. That's just what the particle scale is going to represent. You can also view it if you go over here to geometry, set this to lit spheres. You can see that we have p-scale over time. And this gives us a decent idea of what sort of shaping our explosion is going to take. We also have velocity, and you can enable velocity trails to view your velocity and then add velocity noise to that. This is just for variation. We won't be doing that right now, so no problem there. Now, how do we actually use this? This is where these quick setups are going to come in handy. Generally, you would use a volume rasterize attributes right over here, and then you'd have to manually put in each of the attributes that you want converted, right? So density, temperature, burn, velocity. But there's a really nice way to do it. If we just go to quick setups and just say source volume, it'll convert density, temperature, burn, and velocity into volumes. And we don't really have to worry about this anymore because these are all referenced from this node. So if we remove one of them, so let's just say we remove burn, you'll see that over here, it no longer includes burn, right? So this just kind of automates it for us. Once you've rasterized it, you can put it into a Pyro solver. But once again, we can actually just use the quick setups over here and just say Pyro simulation. This will add its own volume rasterize attributes. And over here, it'll just create this explosion for us. We can decrease our voxel size to something like 0.05 for a higher resolution. And if you want, you can actually fetch the voxel size from the volume rasterize attributes over here. So we have this voxel size. And this is actually going to be fetched from our trailing separation down here, right? So trailing separation, this is going to be our resolution. So if we do 0.5, then the source volume over here is going to have the same resolution as our voxel size in here. That's just going to give us a more accurate representation of what we're getting out of our Pyro Burst node. So it may be difficult to see what we've ended up with just because we're viewing it through here. So what we can do is on the Pyro solver, just go over here and say create Pyro look. This will add this Pyro look node. And over here, we just need to enable fire. And then we can push up our smoke density. Right, so now we're getting an idea of what our explosion actually looks like. You can see that we have these leading trails over here from the Pyro Burst, and then we have this explosion that's evolving from the center. Cool, so that is one way of using it. But this Pyro Burst source has a lot of other options that we haven't really looked at. It has all of this randomization over here that we actually saw in yesterday's node with the cloud shape generate node. The way we use this is by bringing in more points to source on. You can see over here that one of the other quick setups is a single input point, but alternatively, let's just use a grid and scatter a few points. So we'll just scatter 10, plug that into the Pyro Burst, and you end up with 10 explosions all going off at the same time. It's going to decrease the size to 5 by 5, so they're all occupying a similar position. Now, these are all going off at the same time, and that's probably not what you want. So over here, under the Pyro Burst, you all go over to your burst animation, and for your start frame, this is where you'll add a bit of randomization. We set it to set varying, and over here, we can add a variation. So let's say over 10 frames, that's the variation from frame 1 that we're allowing, right? So you'll see that they all go off at different times now, but they all look very similar. So once again, we can also go over to our burst shape and start varying these things over here. Let's just say we want to vary our initial size. We can say set varying, and each one will be a different size. We can also go over here to number of trailings, set varying, drop this to 50, increase the variation. Each one of these individual bursts can actually have their sources individually affected. So we can add variation to each source for each burst. Over here, we can just go ahead and under our sources, just click on this plus minus, that'll add variation. So each one will be varied with their density. And this is going to be your variation amount right over here. The last thing that I'm going to bring your attention to is how we can add variation using attributes. So if we go ahead and select any one of these values over here, you'll see that we have this die at the end. This die over here, if we click on it, it'll add an attribute adjust for us. And this will now control the value going in. You can see that it adds an attribute to our points called spread angle. And the spread angle gets fed into our Pyro Burst source. And that controls that spread angle. You can see that it's now set to use attribute and the value is grayed out. So let's just go ahead and choose a min and max range. Minimum might be something like 15 and the maximum something like 90. You can see that some of our explosions are a bit more narrow and we're now controlling it with this attribute. And again, you can get creative with this. You don't have to feed it into a Pyro network like this. You don't even have to use burn or explosions or anything like that. You could even put it into something like a pop network, right? So if we just feed this into a pop network over here, and just like that, you can have a different type of explosion, right? So this could be for dirt or whatever you may need it to be, right? This is more of a debris type simulation. So this is a really involved node. So I would recommend checking out the documentation for it. There's loads and loads and loads of things that you can do with it. And really a video of 10 minutes isn't enough to cover everything on it. So I would recommend checking it out further, but that is all for this video. I'll be seeing you tomorrow with the Ocean Spectrum SOP node. So until then, bye. Bye.